Buongiorno. Mille grazie a tutti. I would continue in inglese. There is Italian translation. I would like warmly to express my thanks to the organizers of this meeting, and also to my colleague and very important archaeologist Massimo Vitti for the Italian text of my English relation. The construction of huge public buildings in the central areas of ancient cities very often presents a special interest for the history of architecture. Besides, the way in which these buildings are integrated into an already densely built urban environment is of additional interest, sometimes of enormous interest. The Herodes Atticus Odeum in Athens is a prime example of size and architectural quality. At the same time, its construction on this very site is also a case of extremely difficult urban integration. Before going into detail, it is worth recalling the main urban characteristics of ancient Athens. As Thucydides aptly comments, this city, built irregularly around the Acropolis, was generally wheel-shaped, that is, circular in shape, generally speaking, circular. After the Persian Wars, the destruction of the city would, according to Thucydides, have favored the rebuilding of the whole city based on a new regular plan. But then the city was rebuilt more luxuriously, but without a drastic overhaul of the road network. In fact, this plan, as in many other cities with a similar plan, had a clear causality. This convenient functional connection of the different parts of the city and the suburbs following the natural conditions of the terrain. In this context, large public spaces with a specialized functionality were formed and distinguished early in the 5th century BC. The Acropolis and its peripatos, the streets surrounding its base, as the main religious center, the old market, now called the Roman market because of its buildings renovated during Augustus, as a commercial center, and an area south of the peripatos as a cultural center, while the new agora was the political center, a system of centers. In this area, the Dionysus Theatre was the most important public building in continuous use for 8 centuries. To the east of it, already before the middle of the 5th century, the Odeum, known as the Odeum of Pericles, was built, an enormous hypostyle hall with a pyramidal roof. The proximity of the Odeum and the theatre was useful in many ways, mainly because of their obvious functional affinity as establishments. Not coincidentally, this proximity has since served as a model for every other city. In Corinth, Pompeii, Rome, Lyon, Carthage, and many other cities, the proximity of a theatre and Odeum produced a total value greater than the sum of values the two parts would have had if they had been separated. This urban planning principle is still applied today in the best organized cities, so the related functions are deliberately adjacent. To the west of the theatre, built in 180 BC, the two-story Stoa of Eumenes, with a marble facade and staircases at both ends, extended over a length of 165 meters. In front of the Stoa, a 30-meter wide terrace was constructed with a retaining wall along a central road, which ran westwards up to the saddle between the Acropolis and the western hills. Concerning the Peripatos, it is worth pointing out that its course, as fixed in 420 BC, is well recognizable thanks to the preservation of retaining walls and relevant foundations. Nevertheless, for decades after the excavations, the erroneous impression prevailed that the Peripatos completely followed the Humanist Stoa and the semicircular perimeter of the Herodion. This error was corrected on the basis of precise documentation of the material remains by the speaker in 1985, who then drew up the general plan that has since been used in the most authoritative publications. Unfortunately, even now, in some publications, the authors, out of sheer indifference, use older plans. In 86 BC, the Odeum of Pericles was destroyed by fire, only to be repaired 30 years later with money from the King Ariobarzanes of Cappadocia. Nevertheless, the existence of so many interior columns made this building out. In 160 AD, just to the west of the Humanist Stoa and its terrace, the third city Odeum. Next. Yes. This is the appearance of the southern slope before the public works. It is obvious that on the base of excavation finds, the whole south slope was occupied by regular housing. It was a residential area with common houses, since each house was in average 150 square meters, so we can calculate the width of an insula to be in a range of 35 to 40 meters. Therefore, the distance, the intervals between the streets can be calculated into about 40 meters, and in this way we can presume that the number of streets for this stretch from the south, from the Odeum of Pericles to the Herodion, was occupied by 11 or 12 insulae, elongated, ascending from the south to the Peripatos. The position of the streets dividing the insulae could be estimated or found on the base of the bends we still see along the Peripatos. The Peripatos is well preserved, and as it was remodeled in the year 420 to 19 BC, it was the remodeling and the first start of the Asclepieion, the establishment by Telemachos. There is also a famous study by Luigi Beschi pertaining to this specific archaeological issue. And so we, on the base of the bends we observe on the Peripatos, we easily define the positions of the streets ascending towards the Acropolis. You see in this picture the appearance of this town planning. It is not exactly, as Thucydides said, completely irrelevant to any ideas of remodeling the city. There is certain remodeling is observable in this system of streets, but in general the city remained a place with no regular streets. Yes. Exactly. In 160 AD, just to the west of the Eumenes Stoa and its terrace, the third city Odeum was built with money from Herodes Atticus, with a huge theater-like interior and luxurious architectural decoration. The location of this Odeum is not accidental. From a functional point of view, it was the most appropriate since the long-standing coexistence of theaters, first Odeum and the Stoa, gave to the south slope the character and functionality of a cultural center. The first two buildings of this cultural center the first two buildings of this cultural center date back to the 5th century BC, but the area just 100 meters south of the Acropolis could not have been unbuilt. Yes, here you see a problem with the streets. The situation before the construction of the huge Odeum by Herodes. This site was occupied by houses. It is well visible in this restored drawing. The street number 810 is a very important. This is of my Mycenaean times, because parts of it are well documented in front of the Tower of the Nike, close to the Propyla, with rock-cut steps in the Mycenaean manner, and are long being considered as Mycenaean street. There is a bend after the Tower of the Nike. You see on the top of the drawing, you see the tower protruding to the west. There is a bend in the course of this street, a rock-cut street with rock, yes, and towards the Propyla. On the other hand, a very important point along the course of the street is the sanctuary of the nymph, where the famous finds were made, have been made in the 50s of the 20th century by Miliadis, now in the Acropolis Museum. And you see the end of the Stoa of Eumenes. Here you see the end, the west end of the Stoa of Eumenes. So Herodes had to expropriate, to find any means, legal means, administrative means in the city of Athens to expropriate actually 4 blocks of the city. Yes. So the new building had to not just to house the new function, but also to give a solution to the streets being abolished. So it was conceived as a composition of a large concert hall on the one hand, and a system of halls, entrance halls, and staircases, very complicated, able in the same time to serve the traffic inside the building, being used as a Odeum on the one hand, and on the other to restore and to help the pre-existing system of streets further to be in use with only small sacrifices. You see, for instance, the street completely abolished. Only the last stretch of the street outside the Herodes building was still in use, and then a peripheral bypass of the existing system, giving access to the street 810, and again here the street flanking the Stoa had to be also restored in the certain way, using the interior of the building is an example of a building which is at the same time a part of the city, from a function as a yes. The street was abolished when the Herodion was built, and as expected was replaced by a new section that followed the curve of the building from the outside. The location of this new section on much higher ground necessitated the construction of steps. This section did not continue west of the street leading up from the south to the Propyla. In some published drawings of the Acropolis, including my drawings made before 20 years, this is not correct. I was able to recognize this discrepancy later in my studies. Actually, this part of the street was never realized. It was planned, but never realized, because life is always the best criterion for town planners. Town planners are always learning by observing, by studying the everyday life in the city. We have already mentioned that the western end of the Humanist Stoa touched the ascending street. The street is abolished, but the sewer of this street still survives a little further south. With the construction of the Herodion, this street was only abolished as a structure, while its function was retained as follows. The public could use the easternmost staircase of the Herodion, the relevant front halls, and the flight of stairs up to the peripatos, to the outside of the curve of the building. Both floors of the Stoa were accessible through the eastern halls. On the west side of Herodion, another, you see here this system with different options given to the public. There are three options with blue, calmer, and green indicated by colors. One is for the Odeum proper, blue, and the city, and the Stoa. The green is to give access to the Stoa. A detailed study of the above urban planning date in this case, the courtyard of the, yes, next, yes. A detailed study of the above urban planning data of and the sizes of the building leads to the conclusion that it should fit exactly between South Street and the peripatos. In this case, the courtyard would have to be built further south and contain side openings to cross South Street. It appears that it was preferable to move the building to the position it now occupies, so that it would not protrude too far from the front line of the Human Stoa, and the South Street would remain unchanged. The cost of this solution was not small. As we have said, a part of the peripatos had to be interrupted, and the excavated for and the excavation for the formation of the orchestra and cavea to reach for this actual design reached a depth of 12 meters. The above highlights Herodion as an extreme case of a building for the construction of which 4 building blocks would have to be abolished, and the road network would have to be severely disrupted. If the width of the building had been just 5% less, only 1 instead of 3 streets would have had to be removed. So what was the cause of this huge, by local standards, disruption? I say local standards because with standards of the Roman Empire in the city of Rome, such very drastic, very demanding interventions to the city's fabric were a rather usual situation. But for Athens was something by far exceeding any local tradition. Who was responsible for such a situation? The architect or Herodes? Considering the restrictions within which architects, sculptors, painters, and other artists usually worked, considering the enormous administrative complications and time-consuming procedures for the licensing of the and abolishing and substitution of existing roads, it is reasonable to conclude that the main, if not the sole instigator of this urban adventure must have been a very ambitious Herodes. One comes to the same conclusion if one considers the scientific and technical problems posed to the architect and his collaborators by the unimaginable size of the girders necessitated for a roof without intermediate supports. But I will talk about this later. The dimensions of the building far exceed those of other Odea, with width including the entrance halls of more than 90 meters, external diameter of the semicircular part 82 meters, internal height of almost 30 meters, roof height of almost additional height of almost 15 meters, the highest building in Greece up to the time the Hilton Hotel was built. Thickness of the front wall, 2 meters 65. Rear wall, 2.5 meters thick. Dimensions of the proscenium, 35 meters by 8 meters. Therefore, due to the absence of intermediate supports, the largest trusses of the roof must have had an active span of more than 50 meters. The dimensions of the Odeum of Domitian in Rome, as reconstructed under Trajan, are assumed to be even larger, but probably only with a perimeter roof. The remains encased in the Palazzo Massimo alle Colonne are not sufficient for a satisfactory documentation. but the often mentioned Odeum of Carthage, of which only a few lower parts survive, was in fact the theater of the city, while the building behind it was actually the Odeum. Therefore, the Herodion deserves the title of a building with a natural timber roof without intermediate supports, the static span of which is still a world record. Yes. Yes, here you see a comparative table containing all important buildings with large roofs, spans exceeding the common 20 meters. It is next. Yes. Now. Yes. This is a double-decker. This is a British London bus with double-deck. It is the windows, these windows of the upper tile are wide and high enough for a double-decker bus to go through, to run through. Just to give you the impression of the size. Yes, it's clear. A bus is normally 2 meters 45, and this is 2 meters 80, and the height is 5 meters. It is enough for Today's visitors to the Herodion are usually unaware of the roof, and if they happen to have read something, they simply put it down somewhere in the notes. If, on the contrary, they are construction experts by profession, it is completely unlikely that they will accept the ancient testimonies about the roof without any consideration. After all, it is always possible that there is some error in the news and in the ancient sources, and it seems much less likely, especially to experts, that such a huge space could be covered with natural timber without the methods and materials of present-day technology. Nevertheless, in the relevant archaeological and technical literature, the acceptance of the roofing, even without technical arguments, was always almost universal because of the authority of the ancient sources, while the doubters were fewer, based simply on the belief that the huge size of the site disproved the roofing. It is therefore worth mentioning the following first. The following. On the facade, there are windows, original number 34, in 3 successive rows, large enough to accommodate a double-decker. On the carved wall, there were 16 windows of the largest size. Traces of them are preserved near the corners and others of smaller size. The wall is 3 times thicker than the walls of normal theaters. The upper part of the wall, excuse me, there was, I have to explain that because the sizes written on the PowerPoint are lost. Yes, not projected. The thickness of the wall is 2 meters 65. It is double the thickness of the Colosseum wall on the relevant height. and 3 times bigger than the thickness of any other wall on the higher tier of any theater. And there are buttresses protruding to the south. You see one of them, in total 6 buttresses, the 2 middle buttresses connected in a block, in one block. The above proves that the walls were made to bear the weight and of a huge roof, and the windows to illuminate a huge enclosed space. But there is further evidence that also reveals the arrangement of the main buttresses, of the main trusses. The buttresses are already mentioned. Yes, you see the rear wall. The rear semicircular wall is composed of 2 parallel, many transverse masonry walls which divide the interior into vertical compartments, some of which are very well reinforced with cast Roman concrete. This is a common system of emplecton, so-called emplecton in ancient terminology, but at points the compartments are completely filled with Roman concrete. Indicated with blue. 1, 2, 3, the double in the middle, and so on. And here you see the correspondence between the points on the rear wall reinforced with concrete and the points where on the front wall the buttresses protrude. They both correspond accurately, and they indicate the position of bearing of the girders, of main girders of the roof. You see the result in this schematic drawing. But even on this, there are valid considerations. Triangular trusses with a span of 50 meters or more, even if visible, would not be a safe way because they would not have a sufficient safety margin. One can perhaps object that, okay, with these observations, we can prove that the building was made to carry a roof, but such a roof was finally impossible to be built. But for that, the answer is given by the situation found during the excavations. A thick layer of ash and carbonated wooden blocks and nails and broken tiles spread everywhere, covering all the area. And most importantly, the fracture of inside surfaces, walls, and the benches, marble benches, all rounded, exfoliated by fire. It's not the sort of breakage caused by force, by a hammer, or by anything, but typically this type of breakage caused by fire. This is not a chemical, but rather a mechanical phenomenon based on expansion of the surface during heating. The marble and the stone in general are bad conductors of heat, and therefore, if very thick, then during thermal thermal attack, they expand externally, and while the interior remains cool, and therefore spans and stresses are being built, causing the stone to crack in a very conspicuous way, rounded, like potatoes. This is a typical form of thermal fracture. The term is thermal fracture or spheroidal fracture or exfoliation. Therefore, we are now about to think possibilities to design, to imagine the form of this roof. It is proven the roof existed, finally was made and destroyed by fire. By the time Herodion was being built, Roman architecture was well acquainted with arch, with wooden arches, girders not of a normal type of triangular bearing girders, but arches. The architect of the Herodion could therefore proceed with bridge building technology. Next. You see here the achievement by Apollodoros in the year 102 to 104 on the Danube, the famous Trajan Bridge with 21 arches with spans of 40 meters, axial spacing of 55 meters on stone piers. The architect of the Herodion could therefore proceed with bridge building technology, replacing the two legs of each triangular truss with an arch made up of sections, which would greatly favor the effective fixing of the ends on the corresponding tie beams and the reduction of internal stresses by up to 40%. Construction of the Herodion began in 160 AD and was completed in 169 AD when Herodes had reached the age of 67. This drawing and the next drawings explain important stages in the work's progress. At the beginning, trenches for foundations and sewers had to be dug. Could be the second PowerPoint I've sent included many information in Italiano. I've made a very detailed description of all this, translated in Italiano and put on the drawings. But I'm afraid this is not the final version of the PowerPoint. This you see. Up there, the store, the end of the store of Eumenes, they had, of course, temporarily to substitute the original street with the temporary stair, and later again to revise this temporary solution. Then they had to build the cranes, and most importantly, to start only with the central part, that is the auditorium, without building anything in front, outside, or around it, in order to get the cranes as close to the auditorium as possible. Then, after finishing the auditorium, they had to drag the cranes back, say by 8 or 9 meters, and then to start building the scanner and the entrance halls and the staircases. In the same time, they had to completely to abolish, to dismantle the end of the stoa, because the Odeon took just 60 centimeters of the stoa's length, causing a not an important discrepancy in the rhythm of the stoa's orders, Doric order. It is the size of a metope. Then they had, in the same time, to build a shed. You see this shed. Deliberately, they cover the tiles of the shed are omitted in order to make the content visible. They are building a girder under the shed. The girder is 50 meters. Next is the next. Yes, here it is a closer view of that. You see the girder is a arch 52 or 53 meters long. We cannot exactly say how much of that end was provided, but in general, this is the configuration, the configuration of the girder. There are altogether 4 girders of that type. The rest are much smaller and are not to be explained in this context. You see people working, lifting devices, because even the components, very large pieces of wood, were really very difficult to handle. Next. Then they had to build a scaffold on top of which to mount and to build the bridges, like in the Apollodorus bridge on Danube. 60 years after Apollodorus, such, I think, lessons given by the great architect could have been easily followed. And then to be, you see now the cover from the top. Due to the huge size of the building, it was easy to form the roof using straight pieces of wood with not any curvature. It was sufficient just to play with the depth of the notches. You see notches, recesses made to receive the ends of the smaller, the buttons, smaller wooden pieces placed on top of the rafters. And therefore, since in all roofs such cuttings are necessary for the buttons, it was sufficient just to play with the depth of the cuttings to achieve the curvature produced by the roundness of the rear part of the roof. And then, of course, the planking, sitting with, you see, planks, and then putting the tegola, the tiles, pan tiles and cover tiles in a manner already known and covering rotundas or tholoi, like in Delphi, for instance. There is a study by Wolfram Höpfner pertaining to the covering of the tholos at Delphi. And here, then, the very important moment of releasing, of taking the scaffold away. They had to wait and to observe and to monitor the behavior of the whole things from minute to minute in the first hour, from hour to hour during the next 2 days or 3, from day to day for the next month, and after that to decide the time, when the time is coming completely to remove the scaffold. We know such stories by builders, by For instance, Ulrich Grubenmann, who built a wooden bridge of that sort on the Rhine in Switzerland, had the same problem. He decided gradually to lower the formwork, to observe and to monitor the behavior and the shrinkage and this transitional situation needed for the builders to be sure about the success of the work. And to do that, they had two options. One was sand boxes, and the other sand boxes are being used even today in bridge construction. And or by loosening a system of wedges, and then to let people come up and admire the final result. In the book is also some fiction story before. I do not use to put fiction stories in a book, but I've made that twice. Once for the marble transport, and this time with a theatrical play in advance. And this is a moment when the architect lives for who knows for how long, after he is satisfied for the success, because he had the love story in Egypt. And he said he would be very occupied with search for decorative wood, but he had also some personal reasons to live. This is unrelated to the strictly scientific side of the rest of the book. And you see that transversal section of the roof. One half is in the middle, therefore the curvature. The other half to the right is above the pediment, therefore is straight. And this is a longitudinal section. You see the configuration of the main bearing elements, the girders, and the additional auxiliary pieces of wood is next. And some details near the inside and through. This is the anatomical section through the rear wall, and you see the way the sitting benches are ending and touching to the rear wall, and then the revetment with marble slabs, well attested by holes survived by a series of cuttings into the stone made to receive the hooks, iron hooks, and similar devices to fasten the marble veneer against the wall. And also the compartments, and also this is the compartmentation of the rear wall. The finishing of the building, there are splendid mosaics still well preserved under the present-day paving of the forecourt and the area outside the auditorium. We cannot enjoy now the beauty of these finds because everything is covered by the present pavement. And you see drawings in the archive, the F48, made in late 50s, showing exactly this, the patterns used in this. Another is a continuous. The whole thing is 35 meters long by 6 meters, in very rich decorated, plus the similar decorations, pavements, mosaics on all 4 entrance halls. And as for the ceiling, we've, a lot has been discussed about the bearing system, but we can imagine a luxurious, light constructed ceiling, showing coffers, etc., and with moldings, decorations, and gildings. And also all interior surfaces, architecturally decorated. This is drawings made by Versakis, a Greek archaeologist, published in 1912, showing the interior fashioning of the scaena and the proscenium, with columns in the same manner as usual, which is usual in all Roman theaters, but the interesting to this case is that this system of columns and ediculae is only 1 story height, not 2 or 3 stories in many other Roman theaters. Only 1 story height. It is interesting to point that this restoration with 1 story, with the scaena fronts 1 story height, is exclusively a specialty of Greek archaeological research, while other scholars like Tuckerman, the German, who've made the research in 1858, believed that the scaena fronts had 3 stories. Eisenur, we've seen one perspective section before, again believed, but in general, scholars who've never seen or studied the building in detail, quite theoretically, prefer to put 3 stories, while the reality, the evidence survived is only for 1. And there is also here a course of large stone masonry, normally restored as a base for a portico, but in fact it was a temporary construction necessary for the installation of cranes. Also, some scholars prefer to restore at this point a horizontal pavement, a corridor-like horizontal pavement, but there is, we know, no odeum everywhere in Greece or outside Greece with such a corridor behind. In all Odea we know the benches extend up to the wall, and the last row of benches just abuts against the wall. And the people seated on the last had to lean their backs against the wall. This is a rule in all Odea we know. Another rule is the height. Above the last row, the height in all Odaia was considerable for the obvious reason of containing windows necessary for ventilation and light. And this is the final, the final picture showing the situation under the palco scenico. There are holes regularly placed behind the wall of behind the front of the proscenium, and so we can restore the whole thing like this. Capstane argano turn under the palco scenico, and posts installed in holes, vertical holes, extending as deep as necessary, and then a system of pulleys and ropes and rope wheels and the likes, enabling the operators of the capstan to lift this auleum. Auleum, the ancient auleum was in contrast to modern auleum, installed underneath and being raised up, while the modern theaters is suspended from the top. A good example of a like auleum, actually a fence, an iron fence emerging from the ground, is made in front of the Monumento Vittore Emanuele in Rome, in the forecourt, which is emerging from the ground, made a metal construction with the likes. One very old example of that system is still visible in Pompeii, and was studied by scholars for the first time, I think, by Auguste Choisy, the French specialist for historical architecture. But this is the possible, again, this is a risk quite, in the last moment I decided to make a better version of that drawing, but it's not included in this PowerPoint. At any rate, I would like to thank you for your attention.